Hi everyone. Since someone is still entering the webinar, so we're going to wait about 5 minutes, and then we're going to start the webinar for today. So just 5 minutes later, we're going to start. Well, I think we can start from now. And thank you everyone for joining us today for the webinar. And I guess some of you already joined our webinar last week. So this is going to be our second session for the DJI Dock, the global deployment. And I guess we are going to have the commercial sales in middle or end of this month. So we are happy to invite some of the end clients or some of the third-party ecosystem partner to introduce more some actual use case. So the first webinar for the last week is mainly about the product introduction from the headquarters and from the Bill1, our product manager. And so for today's session is going to be the second session for the DJI Dock talk. And then after this session, we are going to have another session in different regions. So today's session is mainly focused on the European. And we also welcome some of the audience or the clients from the APAC and other regions. But today's use case is mainly about what we have done for the past 4 months, starting from the March to now. It's about 3 to 4 months what we have done in Europe. So it's gonna be from the inspection to the first responder search and rescue. So today we are really glad to invite 4 of the speakers, and for me, I'm the host for today. My name is Rick. I'm from the DJI Solution Engineering team and support the European markets. So today we are going to have 4 speakers. One is the Owen John, and also the solution engineer from the DJI side. Is going to represent the DJI to introduce our overview, the progress of the DJI Dock test and deployments in Europe. And then we are honored to have Gemma from the Skybound Rescue from UK. Gemma is the founder of the Skybound Rescue, which has many years of experience of using a drone for the search and rescue to help the people, and also has very many years experience of operating DJI, the joint box solution based on the DJI drone like the Mavic 2 series. Gemma is going to introduce the tests and also some of the benefits of the DJI Dock and also the joint box solution for the search and rescue first responder. And then we're going to have the Alexandre from France, and also from the Alexandre is the president and also the CEO of the Flying Eye, which is one of the very professional dealer of DJI for almost 10 years partnership. Alexandre do some tests with DJI Dock with one of the European top energy clients, Engie, and is going to introduce the joint box solution with DJI Dock for the solar panel inspection, which is a hot topic for the joint box solution. And that is going to improve the efficiency and also reduce the cost for the solar panel inspection. Last, we're going to have David from the Drone Harmony. David is also the co-founder and also the CTO from the Drone Harmony, which also has a long-term partnership with DJI, especially focused on the SDK development. So Drone Harmony has almost every adaptation for the DJI, the drone, and now is the developer, the Drone Harmony Cloud API application and based on the DJI Dock. So, and for each speaker is going to about 20 minutes. And so after that, we are going to have a Q&A session. And if every one of you have some questions regarding the DJI, the product or some of the use case from any of the 3 speakers, please feel free to add your question in the question box. And after 4 speakers' presentation, we're going to have the Q&A session. So to start, I'm happy to hand over to Owen, and Owen is going to present some of the very good overview and the progress in Europe. Thank you. Thank you, Rick.
Okay. Okay, guys. Hi, everyone. Dear DJI customer and the partner, welcome to Dock Talk webinar. My name is Irving. I'm a solution engineer from DJI Enterprise. Probably many like DJI old friends can recognize me because we was hosting several Dock events in last 3 months in Europe. And today I'm very honored to be invited to talk about Dock. And now I have a great news for the market is that Dock is finally officially on sale in European markets. Well, Dock is a remote and automated drone deployment solution, which allows. Okay. Sorry guys, maybe there is some connection problem. 我这里是这样对。Sorry for the interruption. Let's continue. Well, Dock is a remote and automated drone deployment solution, which allows our drones to take off and execute the mission and return to home and charge by himself automatically. So with this function, which allows user to monitor the operation and receive the data while sitting in the office, maybe at home. So we believe Dock as a product is providing more value to customer in a higher dimension. Okay, next we're gonna talk about few milestones since product released. DJI Dock product launch was on last year, on March of 2022. In the early of this year, we sent 9 docks to Europe and we start the European beta test program. And on April of this year, 2023, we add support for live flight control and Fly2 etc. function to FlyHub2, which is very important to enhance the user's control experience in FlyHub2. And 2 months ago, we add to FlyHub2 the flight planning tool, which allow user to create a mission in first perspective, which highly reduce the difficulties of the controlling FlyHub2. And finally, now DJI Dock is officially on sale in European market. Okay, next let's dive into very detail of the European Dock beta test program. On February, we sent 9 docks to different European countries to parallelly start the beta test program in different scenario and in different industry. Thanks to the efforts made by test partner and also DJI local dealer, we successfully accomplished the test program in below scenario, and we can roughly divide them into public safety and inspection. During the test, the product demonstrates very strong stability and functionality. Sorry, is it lagging? Okay, let's continue. We test with SNVVF, which is the Italy national firefighter in mountain rescue. And we test with Skybound Rescuer in first response. And we are very delighted to have, we invited Gemma to introduce their solution later after me. And we test with PSP, which is Portugal National Police in security patrol. And we test with KNRM in beach rescue. And after these slides, I will display a video which was cut by KNRM. Okay, talking about inspection, we test with APG in substation inspection. And we test with ENGIE, which is industry-leading energy sector customer in solar panel inspection. And we test with the Evonik in campus patrol and the Poland National Stadium city patrol. And now I'm sharing a video which was cut by our partner, DJI Dock in beach rescue.
So today we're at KNRM Lifeboat Station Katwijk and we're participating in a demonstration using the DJI Dock. So the KNRM is a volunteer organization founded to help people in need on open water and at sea using lifeboats and search and rescue vehicles. Right now we're using DJI Mavic Enterprise 2 drones in a pilot project to see how we can use them in search and rescue operations. So the challenges we face are the manual operation. Right now we need a pilot and we need to be on the beach to launch the drone, which takes time. The DJI Dock would save a lot of crucial minutes of the notice time we have when someone makes an emergency call. So shaving minutes of our notice time would save lives, since every minute we are at position sooner would narrow the search area someone could be in.
Okay, thanks to AirHub and KRIM as partner who cutting the video. And next, we're gonna talk about Cloud API. Cloud API opens up functionality to Dock to all the developer and the system integrator to set up a private and the custom server, which means that the user can use your own software to control the drones and to save your own data on your own platform, on your own server, pardon. And you can even put the server in your office. In parallel with the European beta test program, we also start the global Cloud API development program. We invite several ecosystem partners to do the Cloud API development. And here are several partners who successfully bring their platform to the market. They are Flightbase and TYGW and John Hamney and AirHub. And today we are very delighted to invite our partner from John Hamney to introduce their solutions with Dock. And besides the industry-leading software provider, we also invited some European local developer to parallelly start the development program in different country, in different language. And I believe after a few months, maybe after summer vacation, there will be various software choice in the market. Okay, next let's talk about the regulation of the operating DJI Dock. To operate an automated solution like DJI Dock, user need to get the flight approval from EASA. There are two options. First is operation with visual observer, which means that you should set an observer to monitor the operation on site. We have very limited scenario, but it's easy to get the approval. And second option is the operation with BVLOS, beyond visual line of sight. We have much wider scenario, operation scenario, but it's kind of difficult to issue because we need to issue the risk assessment. There are two ways to issue it. First is PDRA, predefined risk assessment. Second is SORA, specific operation risk assessment. And several of our dealers are already start to issue the regulation program. Sweden and Italy, they go with PDRA, and Germany, Australia, France, Netherlands, they are go with SORA. And DJI regulation team is providing materials from our as a hardware manufacturer role. We are providing DJI Dock BVLOS technical evidence, and besides that, we are also providing to the markets Matrix 30 series redundancy system reports, where we are helping our partner to issue the regulation problem. And next we are hosting another BVLOS experience sharing webinar in very soon. We will invite several from our partner who successfully get the approval from EASA to share their experience. So we are inviting all of today's audience and some customer who is interested in the BVLOS applying to come into our next webinar, which is coming very soon. Well, that's all from my part. Thank you guys for attention. And in last from my slides, I would like to say thank you for all the test partners who trust us and test our product. Together, we're gonna make the industry better. My name is Irving. Bye-bye.
And come now, bye-bye, I'm just come back. And we just quickly introduce some progress, but actually, like Owen introduced, we have 9 countries at the first stage with 9 docks, but this is just for the Europe for the first stage starting from the March. And in the May and June, we also have the second batch of the dock tests. So it's not just the 9 units test in Europe, and also we have many units tested in North America and also in Japan and some other countries, Australia. So we are going to introduce more and more the test the performance report after we commercially release, and also some of the key numbers, like we already have over thousands of units on commercial deployment, especially in China. So I guess the number is going to increase after we officially sell the units to the global markets. And so like Owen said, I guess some of you will be interested in the regulation part. And also we're going to have the Q&A session, but because regulation is much complex topic, so some of the questions, if you have for the regulation, especially for the BVLOS, we recommend you to contact the DJI local dealer or the DJI solutions team for the region, and we can have more specific topic. For today's webinar, we don't wish to talk too much of the regulation in the Q&A session. So after the 3 speakers introduce the use case, so for the Q&A session, we could focus on the product, the use case, and for some of the discussion. So for the regulation part, like Owen introduced, we're going to have several options in several countries. So once we get the official approval, no matter for the cell 2, for the SORA cell 2 or cell 3 or some of the PDRA, so we can have another dedicated webinar to introduce the experience how to get the BVLOS approval. So next, I'm happy to hand over to Gemma to introduce one of the most popular use case for the joint box solution as the search and rescue first responder. So Gemma, we're going to hand over to you.
Cool.
Yeah. We're going to close the network. Yeah.
Cool. Good morning, everyone. I'm Gemma Alcock from Skybound Rescuer in the UK, and I have some really exciting public safety plans for the DJI Dock to share with you all today. And at the end, I will show a video that will bring those plans to life for you. So I hope you're as excited to hear about and experience our plans for the future of public safety as I am to tell you. But first things first, you need to get to know who's talking to you. So who am I? So I'm Gemma Alcock, and I have 2 main roles within the drone world. Firstly, I'm the founder and CEO of Skybound Rescuer, which I'll come back to. And secondly, I'm also the director of air operations for Lowland Rescue, a UK charity that searches for missing vulnerable people from hills to high water on behalf of police forces all across the UK. And as the title suggests, I manage the air operations, so from how we interact with these search and rescue helicopter services to how we use and manage drones within the charity to find missing people too. But today I am here speaking on behalf of my company, Skybound Rescuer, of which I am founder and CEO for. So who is Skybound Rescuer? We are a team of experienced emergency managers that specialize in automating drones for public safety. So since founding the company in 2016, I've been researching into best practice for every phase of drones for public safety, from training and competency management to drone procedures to command structure to mission tactics and everything in between. Until recently, our services included consultancy and research for drone tech companies wanting to explore public safety, but also for emergency services wanting to explore drones. But since December 2020, our business as usual has been changing. We've been working on Skybound Rescuer 2.0, if you will, which is what I'll be talking about today. And you're some of the first people to hear about it, so I promise you it's truly exciting. But firstly, I need to define the problem that we're setting out to address with Skybound Rescuer 2.0. So firstly, it is undeniable that air support in all its forms is an integral component of modern emergency services, offering better situational awareness for enhanced safety and saving valuable time when it matters most to ultimately save lives. However, there does remain significant problems with the current air support services. And these causes and problems are something that all emergency services around the world experience every single day. I've included some UK example stats on this slide to contextualize these challenges. But these causes and problems are not contained to the UK alone. So firstly, the expensive nature of conventional aircraft causes low availability. For example, police helicopters across the UK are available on average 54.9% of all requests, meaning that the police helicopters decline almost half of their requests because they're unavailable to respond. They simply cannot meet their growing demands. Now, not only are the aircrafts expensive, but the helicopter bases, their operating bases are too, which means they are few and far between. For example, there are 10 Coast Guard helicopter bases to cover the 2 million square miles of the UK search and rescue region. This, combined with the very manual request process, causes slow response times. The slowest average response time in the UK is experienced by Cumbria Constabulary, which is 66 minutes, even when there's life at risk. And then we come on to manual drone teams, so teams that are in the field flying drones manually. Although the potential for drone technology is undeniable and is growing in evidence, performance data and research trials have also highlighted some performance concerns. So currently, we have relatively small drone teams that are responding to large areas. In addition, they cannot, in most cases, fly direct to the incident site. They have to drive their vehicle with the drone in the back before they set up and start flying. This causes slow response times and low availability. And I've personally been involved in many searches where we've had to wait hours to days to get a drone team on site. Drones are rarely the first on scene, and yet that is where they'd add the most value. And lastly, local teams around the world have been working in silos when setting up their drone teams, which means there are no national or international standards for the drones they use, to the training they receive, to the mission tactics they follow, and more. It can differ vastly between two emergency services operating in one county, let alone nationally or internationally. And yet the importance of joint emergency service interoperability is so well known in this space. So this is causing varied unreliable performance levels. So all things considered, air support is often the greatest advantage to emergency services because of the higher height of eye advantage and the real-time situational awareness picture that it can offer. Therefore, these problems are causing greater risk to the public and to the emergency services through inefficient air support. If air support is not on scene fast enough or it is unavailable to respond at all, then our emergency services are having to proceed into dangerous environments without an eye in the sky to protect them. Or they are having to spend hours searching an area that could be covered by an aircraft in minutes. And this is the problem space that we're setting out to address with Skybound Rescuer 2.0. So the first part of solving this problem was developing our new automated drone software, the Skybound Coordinator. Since December 2020, we have been turning our 7 years of research and data into algorithms that can automate data-driven mission plans for public safety. Our first two use cases have been missing person searches and crime response. The use case that I'll explain today is missing person searches, or search and rescue. These algorithms pull on a variety of databases like missing person behavior statistics and data from our own trials into things like optimal flying heights, optimal flying speeds, and more, all to better find missing people faster with drones. It also quantifies performance because no two searches are the same quality. For example, we could be searching flat terrain with cut grass in daylight for a person wearing bright red clothing and a high visibility vest. Then we could be searching hilly terrain with tall vegetation in darkness for a person wearing dark clothing. These two searches won't have the same performance, but using current terminology, we say that area has been searched by a drone and that area has been searched by a drone, with no instant indication of these differences. Whereas our software will quantify its performance, so that search managers can make informed decisions about whether that drone search was sufficient, or whether the drone needs to search that area again, but with different parameters, or whether a different search asset is needed altogether, such as a foot team or boat team. So this software is packed full of many other pre-flight features, all informed by our in-depth research. And it's also packed with many in-flight features to enable teams to collaborate more easily to find missing people faster. It also generates an automated post-flight report that summarizes and analyzes its end-to-end performance. But this software is just one piece of the puzzle, though. It addresses the need for standardized, repeatable performance, but it does not tackle slow response times, low availability, or the need for cost effectiveness. And this is where the DJI Dock comes in. Allow me to introduce you to the bigger picture, the Skybound network. We are rolling out a network of automated drone stations such as the DJI Dock in hotspots of risk, such as at popular coastal locations, whereby any emergency service can task the drones on demand through our software to save and protect lives. And our software aims to unlock this vision. By using automation technologies, the drones can always be ready to respond, and there will, in the future, be no need for an on-site drone pilot. This, combined with being stationed where they're most needed, means it aims to offer a rapid 5-minute response time to these high-risk areas, and that is 5 minutes from a request coming in to the drone arriving on scene, which is, to put it into context, 55 minutes faster than the Coast Guard helicopters in the UK. It also aims to be the most cost-effective air support service, firstly by being a shared multi-agency network, but also reducing the amount of human power required from each agency by the use of automation technologies. But also Skybound will retain ownership of the infrastructure, and emergency services subscribe to the service for the use and access of the drones instead, to remove capital costs from their budgets and to ensure that they always have access to the most cutting-edge drone technology. The affordability of our infrastructure compared to helicopter bases means that we can have hundreds across a country rather than double digits, which will improve availability as well as response times, as well as cost effectiveness. And of course, through the Skybound Coordinator, the decision making will be repeatable, it will be automated, and it will be data driven through our 7 years of research and counting, in order to standardize drone performance to the same high level every single time, shared by every single agency. Before I get to premiering a very exciting video, I'd like to demonstrate the value of Skybound Rescuer 2.0 by sharing some really exciting research results with you from recent trials. So I'll give you a few seconds to take this in. I know there's a lot of information there, and then I will take you through it. So the column on the left is our performance. We took 8 minutes, 1 second to respond. We took 13 minutes, 39 seconds to search the area. And it took one person. And importantly, that one person had no formal drone training. He had never flown or even touched a drone before. And he was the one that created the mission plan that flew the drone. That is a key goal with our software, is that someone in a control room that has never seen a drone before can create a mission plan as easily as an experienced drone pilot. So it's a very simple request form that needs instant intelligence only, and that request form generates the entire drone mission plan for then one of our drone pilots to activate it. And most importantly, we had 100% search accuracy across the test too. The middle column compares these results against a foot team, and the right column compares these results against a manual drone team. We tested them under the same conditions, the same area, the same search targets, same scenario, all things were equal. And we responded significantly faster than both. We searched the area significantly faster than both. We reduced human power significantly for both. And in the case of manual drone teams, we also improved search accuracy. Now, speed in terms of both response time and search speed combined often act as a proxy metric for survivability. The faster we can find them, the faster we can deliver them to definitive care, the better the chances of survival. These results demonstrate the truly life-saving potential of the Skybound network. And now, to really bring it to life for you, here's a premiere of our Counting on Drones video that paints the picture of the future we are striving for.
We count on our emergency services in our darkest hour. Now we want to be there for them. A network of automated drones that our heroes can count on. Air support keeps them safe. Air support keeps us safe. Air support can make all the difference. Because the people who are brave enough to keep us safe deserve our support. Counting on us. Counting on drones. Counting on the Skybound network.
So thank you for listening, and I hope you're as excited as we are for the future of public safety. Thank you.
Thank you, Tim. I'm going to take control back. And as Gemma said, public safety is one of the mainstream use cases and probably also the most popular use case for the dock and for any kind of the joint box solution. So, and also what is special for the Gemma and the Skybound is that they have their own software, no matter for the operation software, and also they develop the software based on the cloud API to directly control the DJI Dock. So for other regions, if you have such kind of a software demand, you can also reach out to Gemma, and probably you can also reach out to DJI for some other third-party operation software recommendation. But anyway, the first responder or the public safety is very good scenario for the DJI Dock. And public safety always popular, and another one is for the inspection, especially for the solar panel inspection. For the past several years, we find that the solar industry is improving a lot, especially in Europe. And one of the pain points is how to do the inspection more efficient and much cost effective. So one of the ways to use the drone to do the inspection to replace the human. We also find to have the pilot on site to do the panel inspection will cost a lot of human resource. So a joint box solution probably will be the best solution to solve this. We can improve the inspection efficiency and improve the inspection frequency. So this is what we do with Alexandre in France. So we're going to hand over to Alexandre for the solar panel inspection use case sharing. Hi, Alexandre, could you hear us?
Hello. Good morning, everybody. So I'm Alexandre Thomas. I'm the CEO of Flying Eye Company. We are a DJI dealer in France, and we have been testing DJI Dock since a few weeks now, and we were able to share the DJI Dock with several companies. One of them is NG, and I will show you today a use case with NG solar farm. So first thing first, Flying Eye is a DJI enterprise distributor on the French market since almost 10 years now. We mainly focused on public safety and energy sectors. Our company provides drone solutions for improving safety and efficiency. As an example, Flying Eye is partnering with companies such as RTE, French electricity transmission operator, NG, and Total Energies. As an official DJI Enterprise Gold partner, we offer the best expertise in the professional drone sector. About NG, so NG is one of the world's leading energy companies. With a presence in over 70 countries, NG is a leader in the energy transition. Its aim is to provide sustainable and innovative solutions to the energy challenges of our time. NG is engaged in the production and distribution of electricity, natural gas, and renewable energies. The company stands out for its commitment to promoting energy efficiency, reducing CO2 emissions, and developing clean energies. So we are partnering since almost 10 years with NG Lab Creation, which is NG's corporate R&D center dedicated to green gases like hydrogen, biogas, and liquefied gases, new uses of energy in cities, buildings, industry, emerging technologies like digital and artificial intelligence, drones and robots, nanotechnologies and sensors. NG Lab Creation conducts operational R&D projects, develops pilots, and implements innovative offering to stimulate and accelerate the energy transition. NG Lab Creation brings together key skills on testing facilities that are unique in Europe to prepare the energy solutions of tomorrow. It also accelerates and strengthens collaboration between French and international R&D ecosystems. In a few words, ENGIE is supplying today more than 3 million people, over 1,000 communities and companies, and produces 22 tons of CO2 emissions. Over the years, ENGIE has invested in various solar technologies using ever more innovative solutions. The photovoltaic park of ENGIE has a total capacity of more than 5 gigawatts worldwide. It is also the largest in France with 9% of the market, and it includes concentrated solar power plants, organic photovoltaic, centralized and decentralized production solutions, sometimes combined with energy storage. So we will summarize the needs of ENGIE on solar plants. The first need is to monitor the site against intrusion. ENGIE needs a good solution against intrusions because they face copper theft and danger of electric shock while intrusion. The DJI Dock provides the constant observation of the site. Thanks to the thermal camera, it can spot intruders even during nights and under the rain. The second needs of ENGIE is to maintain and inspect solar photovoltaic panels. ENGIE needs to spot the slightest underproduction in order to optimize operational performance. Indeed, the slightest vegetation can shade the panels. Any clogging, mechanical stress, like a strong wind, and deterioration of the solar panel needs to be quickly identified to enable predictive rather than curative maintenance. The exact position of the panel concerned will be geolocated, and its serial number can even be identified remotely from the DJI Matrix 30T drone. A third and major concern from ENGIE is the safety. Operators regularly work alone on site, so in the event of an accident, illness, fall, injury, etc., the drone can transmit information regularly to the surveillance patrol, for example. The DJI Dock will be able to keep an eye on an entire site or several of them and share the information instantly to the control center, even from a remote location. Here you can see an example of a DJI Flight Up 2 mission for the inspection of the solar panels of a solar farm. In this example, you can see the DJI Matrix 30T will cover a wide surface in a single flight, and it will take hundreds of shots, meaning each shot is containing one visible image plus one thermal image for analysis. In this view, you can see, probably it's too small, the flight distance is more than 14 kilometers during a flight of 23 minutes and a half, and it will take 1,400 photos. And this is an example of one visible image and the associated thermal image shot during the inspection mission. Both the images are used to spot the defects. On the thermal image, you can see on the bottom left part, there is two panels with defects, and the visible image can also be used to verify if it's only dust or real defect. I will now explain shortly the workflow for the solar panel inspection. First, mission planning, which is critical to obtain the appropriate results, should be set up. For example, you need to think about the irradiance of the site, the choice of optimum ground sampling distance, the flight altitude, and the overlap parameters for your data collection. Working in the descent light at a lower altitude will produce higher fidelity data and better results. But in the opposite, the mission will take longer to complete. So parameters are critical. For regular inspections, these flight parameters can be recorded and repeated to provide comparable data over time. The second step is launching the mission, which can be done through the control software. The drone takes off and begins a predetermined mapping flight, progressively collecting and downloading data as it flies. Data collection is autonomous and cloud-based from start to finish. The thermal and RGB images are collected automatically. The third step will be the real-time synchronization and anomaly detection. Indeed, the solar farm asset inventory is synchronized and analyzed in a matter of seconds. All anomalies and defects requiring special attention are highlighted in the software, like cracks, delamination, yellowing, etc. They are recognized and identified in the software. Then a digital twin of the photovoltaic farm is created, integrating 2D and 3D data, as well as the electrical data, logic diagrams, and the serial numbers of the panels. Fourth step will be the data exploration. Data from the drone can be explored as it arrives. Individual panels can be selected from the software for a closer examination, with different color map options available to enable easy defect detection. And the last step will be the automated post-flight reports. They were generated at the click of a button, providing clear information and actionable data for maintenance teams. Then all actions can be taken quickly to lower the loss of production. I will now show you a quick video made by the lab creation of NG during our use case. Thank you all for your attention. I stay available if you have any questions. Don't hesitate to contact us. Thank you.
Thank you, Alexandre. Thank you. We're going to make the presentation, David. One thing to say, we know, like we said, solar panel, no matter for the regular drone or for the drawing box solution like DJI Dock, the solar panel is always the hot topic for that. So we, from DJI side, we also do a lot of work, no matter from the business development side or also from the solution side. So probably in the Q3, we're going to have a dedicated session for the sort of industry. So we're going to explain more details about the DJI Insight for from the business opportunity and the workflow, and also some other third-party solution recommendation. So we are going to give the agenda once we confirm. So last part is going to be the cloud API. So because some of the clients or the dealers are talking about if whether the Fly Hub 2 is going to comply all the customer demands, because the joint box solution is going to be more complex, no matter from the hardware or software. So different clients regarding different industry have a different demand, whether the Fly Hub 2 from DJI side can comply them all, or what else they have other options. So because for the dock, we don't have the pilot, which means we don't have the mobile SDK option for the DJI Dock. The only choice to open the DJI Dock capability is based on the cloud API. So how the third party developed the cloud API to use the DJI Dock, and what other companies can use the cloud API to do with the DJI Dock. So as we have a long discussion with Drone Harmony, so they also have their software ready for the DJI Dock. So it's a great honor to invite the Drone Harmony to present their solution, and also to show some of the videos how they are going to use the cloud API to do the flight management. So we're going to hand over to David.
Thank you very much.
1 second. Yeah.
Perfect. Let me just start my share here. Is this coming through okay? Rather here.
Yep.
Yes, it's okay.
So hello from my side as well to everyone. Thank you, DJI and the other panelists for the invitation, for your presentations before. My name is David. I'm one of the founders and CTO at Drone Harmony. And today I will tell you a little bit about our solution for the DJI Dock. And specifically, as was already mentioned by Vic, we are one of the integrators of the Cloud API. We've been enjoying collaboration with DJI on this for the last months since the Cloud API has been available for partners. And the results of that is what I would like to present to you today. So a few words about Drone Harmony. We're a software company. We've been around for about 8 years for now. And we've been actually developing for DJI drones for at least 7 out of those 8 years. And our solution range is addressing until today primarily, of course, the classical way of controlling drones using remote controller and drone. And it was very exciting for us to have the opportunity to also work on the DJI Dock once it's been released. A bit about the company. We are a Swiss company based in Zurich. We're a software company, and we have a few tens of thousands of users. We've been around for quite a while, and it's been, and for almost all of our existence, we've been working with the DJI SDKs, and the Cloud API is a new addition to our portfolio in some sense, but it's been something we've been working with for a long time. So we focus on flight management and flight planning, flight execution as well, everything related to data acquisition essentially. And our solution is, of course, a cloud-based, or let's say a web-based application. I'll talk about the different server configurations later, but essentially it's a software solution that runs in your browser. Another slide about why Drone Harmony and how Drone Harmony does things a bit differently from other solutions. Basically, traditional flight planning and management, as many of you here will know, is it's kind of an interplay between different types of data, actions, software packages. So sometimes GIS data has to be a basis for flight planning. We sometimes want to see our flight plans in 3D before we execute them. We have our flight planning tool. We have a ground station software, of course, the hardware, the drone. And once the data has been collected, we have some mode of storing the data, maintaining the logs, etc. So a lot of times those things are, while the workflows are set up, there's those let's say workflows are distributed between different software solutions. And in Drone Harmony, we try to bring all of this under one umbrella. So Drone Harmony is essentially, you can think about it as a GIS platform which can host and visualize all of your relevant data for your flight planning, flight execution in one place, and then also overlay the captured data and the relevant log information. It also includes the ground station. Of course, there's no ground station in the DJI Dock case because the Dock is its own ground station software in some sense, but the flight management can happen within the Drone Harmony platform, of course, as well. So at this stage, what I'd like to do is, instead of running you through features, I will first show a small video about the platform, how it looks like, how it feels like, and then we'll go back to the slides. Okay, so this was a quick video just to give everybody a little bit of a feel of how it feels like to work within the Drone Harmony platform on various use cases, a little bit to touch upon the different industries that we're trying to address with our solution. Let me just flip back to the presentation here so that we can continue there. Okay. So our solution for the DJI Dock, essentially Drone Harmony, what we've done is we've taken Drone Harmony's quite well developed flight planning and data acquisition platform and adjusted it for the DJI Dock use case. In essence, our platform has been initially built with the idea of a type of for this kinds of use cases where we maintain a clean digital version of our physical site within the software, and that helps us plan missions, visualize both capture data and derivatives of the capture data, things like point clouds, custom maps, etc., in the virtual environment to make better, quicker decisions about how to capture the next data set, how to send the drone for its next mission. So I'll touch a little bit upon the different features. We've already looked at a bit of the industries that we're trying to address. We're addressing industries such as perimeter patrol, inspection and mapping, as well as things like mining, construction, everything that's related to managing flights in a complex three-dimensional site is a very natural fit for the Drone Harmony platform. So on the situational awareness side, essentially, we have within the software all of the live feeds from any number of docks. That's an important aspect. So we can connect any number of DJI docks to the Drone Harmony platform, and one operator can view all the feeds from a single interface. There's no need to have several screens or something like that. So we can have kind of a many-to-one situation where we monitor several sites. We can have views, of course, on all the telemetry, on the status informations, warnings. All of that is kind of intuitively presented to us within the platform and overlaid whenever it's some geolocated data, things like images, location of the drone, etc. It's always presented in the virtual environment in its actual geolocation. So, for example, what we see here in this pictures, we have the drone location and orientation presented. So as the drone is flying, we see where it actually is also in the virtual environment. So of course, we can launch missions, we can pause, we can resume, we can return to home, all of the natural things you would expect such a software to provide. Scheduling missions as well. One of the main, let's say, features of Drone Harmony is its very, very rich ability to plan missions for various kinds of use cases. It's something that's kind of inherited from the Drone Harmony platform. The philosophy within Drone Harmony is that when we import GIS data into the platform, it should stay there, it should live there, and it should be useful in more than one way. So in particular, it should be useful it should be possible to use it for flight planning, not only for visualizing the data. So in this case, what we have is an example of a power line inspection where we have both vector and raster data combined, and we can plan missions based on that. There's quite a rich variety of GIS data that can be used within the platform. So that's raster data, things like terrain and surface models, vector data, and point clouds is something new that we've added right now, as well as custom maps, so 2D maps, orthomosaics, etc. On the image management side, so as soon as the Drone Harmony, as soon as the drone lands back in the dock, all of the images and metadata is automatically uploaded to the Drone Harmony cloud and presented in a very intuitive gallery view, as well as overlaid on top of the map. So So in this case, what you see here on the right is the same data you see here on the right, the gallery views. Those are generated automatically as soon as the drone lands back in the box. On the side of site visualization, I've touched upon this already before. We have very, very rich capabilities of visualizing sites. So essentially, any kind of data can be put into the Drone Harmony system and used at least as a visual layer. But in many cases, those forms of data can also be used as basis for flight planning. So we have some examples here with vector data for example, buildings and structures, as well as raster data, things like surface models. And when we import, for example, custom maps, we can easily use them to outline new things. So we have very, very rich map tools that allows us to also select things, move things around within the interface to just create the perfect digital model within our system that would help us plan flights, visualize them, and control our DJI Dock solution in the most intuitive and automated way. We also support our users with flight safety features. So one important aspect of that is geofences and no-fly zones. So those are kind of native features of the Drone Harmony platform. And what we offer in the DJI Dock use case is the ability to kind of decide what should be the behavior of the system if a certain flight, a mission that's been planned, violates some of these conditions, as well as during flight if there is a violation of these conditions. And here we work with DJI, with the dealers, with distributors to understand what's the best workflow. And our system is very dynamic in that we can adjust and tweak various things to fit a certain use case. And if, for example, it's needed to have a certain behavior to receive a certain authorization in some country, that's something we can very easily support with. And no-fly zones, geofences is just one example, but additional flight features can also be tweaked. For example, we can overlay data that comes from ADS-B receivers, from basically UTM data of various kinds on our interface in order to add additional situational awareness and flight safety layers. So we're very, very keen on collaborating on the flight safety side with our customers and with our partners. Finally, a few words about site and dock management. So Drone Harmony is a platform which is not a single project, single dock kind of platform. As I mentioned before, we have a kind of a site management system within it. So what you see here on the map is essentially 3 or 4 different sites. Each of them can have more than one dock associated with them, and all of them can be loaded and visible and accessible through the interface at the same time. On the right, you see kind of our sites management panel where we have access to all of the different components of a site. But essentially, in use cases where a single person needs to control several sites, Drone Harmony is designed for those kind of use cases too. Now, a little bit to the technology and to the technical aspects of things. So Drone Harmony provides a custom server solution for the entire platform. So that means that you can install the whole infrastructure that we need, is the whole server part on the premises of the customer. That means that there is no direct access to the internet, so you can install it on the IT infrastructure of the customer and connect through a private network to that server from all the clients. So basically from all the users within the organization, and that way there is the data security level that's sometimes required for customers which have sensitive infrastructure and want to have an on-premise version of the solution. So we have an on-premise version. The platform is completely Dockerized. We can install it on any IT infrastructure, and the constraints are very, very, very low. We don't need anything special. Essentially, a very simple server configuration. We don't need any cloud services. So essentially almost any IT infrastructure is good enough to run Drone Harmony. Of course, we also have the cloud version. So if a customer doesn't want to bother with on-premise, they can of course use the Drone Harmony cloud to access the platform. No problem at all. Our cloud runs in a Microsoft Azure server in the European Union. And there are some intermediate versions, so that's more for our partners. Some partners like to host on some certified server one Drone Harmony server and serve several customers. That's another option that we offer, and we're more than happy to engage in conversations about making such a setup with anyone, partner or customer. Another very important aspect of our platform is the rich interfaces that we've built for it. I've mentioned only 3 options here, but those are the ones that I think cover the most important aspects of the DJI Dock solution. We have an API for the platform. The API allows essentially integration of all of the capabilities of the Drone Harmony platform within other web applications. So in particular, if you have, for example, a data management platform for some kind of inspection workflows, if you want the flight planning piece of Drone Harmony, that can be very easily integrated, and we can make server-to-server connections to make sure that the data that comes from the DJI hardware into Drone Harmony flows through the API directly into that other platform. So that's one aspect of it. But in addition to that, we are very open to integrating UTM, so unmanned traffic management information, to make sure that we have the right safety requirements met and to allow various kinds of authorizations to be reached. So we're very interested in collaborating on making sure that our solution on the software side meets the regulation requirements in the different countries. So that's very important. And finally, integration of external sensors. So essentially, we have the capability of opening a generic, open a generic kind of WebSocket or a socket through which we can ingest information from external sensors. So those can be, for example, cameras, alarms, smart fences, anything like that. There too, we're more than happy to collaborate with partners to understand what are the most important sensors to integrate, how to go about doing that, and making sure that our solution fits into the bigger picture of solutions. We've seen amazing solutions and ideas and products already today. So we're open to collaborating on any one of these fronts. What we're providing is the flight management kind of Swiss Army knife tool that has all the functionalities and has customizable parts that would fit into many workflows, in particular perimeter protection, inspection type workflows, mapping type workflows, etc. So that's the end of my presentation. I hope that was interesting, and I include my email here below. Everybody's more than welcome to write me directly in case there is interest in any of these things, and I'm too open for questions. Thank you for your attention.
Thank you, David. Thank you for everyone, and Gemma, Alexandre, and also David for the presentation for the different areas insights, including the use case for the first responder public safety, and also for the inspection, and not just for the solar panel. And I guess the inspection will be all the same workflow for other industry, and also the cloud API development for the Drone Harmony. So we are going to have around 10 minutes question and answer, but I guess we don't have too much questions. So we got several for the DJI side, and the first one is it's about whether we're going to have the M350 dock. The answer is clear. We do not have the plan. Even before, we don't have the dock for the M300, and also now we don't have the plan. At least for the coming 2 years, we don't have the plan for a dock solution for the M350. The second question is about whether M30 is a good survey drone. Like we said, our recommendation, if you look at M30, it's a very good drone for the inspection and for the public safety. For some of the area, but from the camera, the physical camera, the M30T or M30 is not designed for the surveying level. So we can do some of the work if the accuracy demand is not so high, like for some very quick 2D map for the public safety usage. If we look at some very accuracy demand, like for a line of survey for some of the construction progress monitoring, for now we don't recommend to use the M30 Dock or the M30 for that. But overall, we still recommend to use the M30 Dock for the inspection and also for the public safety. So we still got several questions for the speaker. One is for, I guess we don't have, one is for Alexandre. We have two questions, well, we can combine them together. So the question is for the solar panel of the Flying Eye and the NG use case, which camera software was used for generating post-flight analysis report? I guess it's for the post-data analysis software. And the second is more details about which camera software that Flying Eye and NG are using. Does it support M300 RDK with its 20T? And then it will be the price and the cost. Hi, Alexandre.
Hi. So to answer the questions, NG are using, as it is NG Creation Lab, they are using several softwares because they are trying to find the better workflow. I know they successfully used software called Raptor Maps. There were already some blog on DJI Enterprise website about it, and it's giving a good result. At the moment, there is no software linked to the mission planning of Dock, but I think it will come very soon now, either from Raptor Maps or any other software. NG Creation Labs, they are also working on in-house software, on in-house automation of treatment and reporting of the data. But I can't share more about it at the moment. So yeah, that's what I can answer now.
Okay, thank you. The second question goes to, let me check. The question will go to David, and what kind of feel safe are available with Drone Harmony platform? I guess it's some features for the Drone Harmony platform after the fly fields.
It's about fail safes.
Yeah, fail safes.
Okay. So basically here we are we're experimenting with various options, but basically the answer to that is that we can implement various kinds of fail safes, and we're more, let's say, listening to our partners and to understand what fail safes are needed in order to make sure that we maintain safe flight operations and approvals for using the full solutions, the dock, the software, and the process around it. Now, I'll give you an example just to exemplify what I just said. So, for example, I touched upon the no-fly zones part. You can define no-fly zones within Drone Harmony, and you can make sure that, and Drone Harmony knows whether a no-fly zone is being violated during flight, as well as during the planning. So we plan a mission. If the mission violates a no-fly zone, we mark it red or bad in some sense. Now the question is, what should you do? Some some countries, or let's say some solutions, might want you to prevent the user from ever launching such a mission. We can do that. In other cases, it might just be okay to give a warning and to kind of flash the warning on the screen and say you're launching a mission that violates a no-fly zone that was defined for this site. And that's also something we can do. So we have the flexibility there to kind of adjust to the needs of the use case and of the customer. The same for during flight. We of course know whether the drone is violating during a flight no-fly zone. So we can, in option 1, we can, for example, offer, we can kind of prompt a message that said you should probably return to home, you're entering a no-fly zone. It's also conceivable to just block in some sense or stop the mission automatically at that point. Again, all of the controls that are available through the Cloud API are accessible to Drone Harmony, and we can design a workflow that's meeting the specific needs of a use case. And there is no kind of one-fit-all there. I think there'll be different use cases requiring slightly different approaches to these things.
Okay, thank you, David. The next question will go to Gemma. The clients wanted to do for you to do a comparison for the Skybound Rescue between Dock, Manual, the drone team. The comparison Skybound Rescue between Dock and Manual drone team. I guess this is some want to learn more about how you are going to use the joint box solution and versus the manual drone operation.
Yeah, so we aren't trying to have total coverage of a country with automated drone stations like the DJI Dock. Instead, we are trying to find hotspots of highest risk to have rapid response. So in between our coverage, we'll still need coverage for other incidents that occur. So that will be manual drone teams, that will be the conventional helicopter services. So we want to blend into that current picture to have really rapid response where the risk is highest, basically. Because incidents don't happen in equal measure across every part of the country. They often are clustered in certain locations. So there'll be popular coastal locations that are more at risk for drownings, for example, because more people go there, perhaps. There'll be parts of cities that have higher crime rates than other parts. So that's where we come in. We're looking for those highest risk hotspots to put an automated drone station there and have really rapid response where the risk is highest. So we're not trying to replace manual drone teams or replace helicopters or aeroplanes. We're trying to blend into that picture and have rapid response where it's most needed.
Sorry, Gemma, I just want to get the feedback from the audience. Just want to clarify the question is you do have an efficiency comparison for the manual team and also for the joint box solution team. The question is whether you are using the same drone, like the manual team use the M30 and also the M30 joint box solution, which means the efficiency comparison is using the same drone or not a different drone.
Yes, so all things were equal. We tested with the same drone.
Yeah, okay. And the next question also goes to you, but the question is very long. So we simplified to ask about your plan about how you are going to design, how many units you need for the UK, about how many units you need to deploy according to your estimation. It's about the logic, how many squares you need for one dock.
How many? So how many docks or automated stations across the UK? Is that the question?
Yeah.
Yeah, so as I mentioned, we're not trying to have total coverage. We've developed a methodology that identifies, it's a GIS interactive map that scores all of the UK in terms of lots of different risk scores. And so it's given us, at the moment, it's given us 500. We're now reviewing those and we're going to down select to 200 to start with. So yeah, it's hundreds rather than double digits like helicopter bases. But it's still not going to be total coverage of a country. It's just identifying those hotspots.
Okay, thank you, Gemma. We still have too many questions, but we don't have too much time. So the last one is we are going to answer one question. For the rest, we're going to collect and we're going to send the question to the audience. So the last question is about whether the DJI Dock can be used on a moving platform. This is a general question. But if we look whether DJI Dock can be used on a moving platform, the answer is we don't recommend to put it on a mobile, because every time when we fly the M30 Dock, we need to get the RTK convergency, which means we need to get the RTK convergency, and then take off. But every time if you put something on the trailer and to put it in another place, every time we can support, but every time we need to set power on and get RTK convergency and take off, which means every time you do that, we have to do that again. Like we needed to put the dock coordinates into the dock system. So it will take about half hour to do that. But more specifically to your question, whether we are going to put the dock on a ship, I guess it's going to be more difficult because the ship, especially is moving, is not stable. So it's really hard to get the RTK convergency, and especially for the dock to land safely. So to answer that quickly, we recommend to put the dock in a fixed area. But in some of the scenarios, we can put on the trailer or some of the truck to support mobile deployments. But it will take about a half hour every time to set up. And we don't recommend to put it on something like the ship because it will be dangerous. We also have some other questions about ADS-B and also some other safety related. So we are going to collect all the questions. We are going to send the email back to the audience. So thank you, everyone. And I think it's going to be today's webinar. And again, like we said, we're going to collect all the feedback, the question, and we're going to answer your questions through the email. And also, we're going to forward the question to the related speaker, and we are going to follow up. And again, thank you everyone for the time to join in today's webinar. And like we said, the DJI Dock is going to be commercial in the middle or the end of the July. Then you can now contact our local dealer for some of the information, and also do the preparation for the commercial units. And I wish we can have a lot of good projects for the DJI Dock. And last but not least, we also have some following sessions. This session is mainly for the European test progress, and also we have some other sessions in like Australia and also in the North America. So it's going to be the coming week and weeks. So please follow up the DJI channel and the DJI GoToWebinar platform. And we're going to bring more use cases from other regions. And thank you all, and goodbye. Have a good day.
Bye-bye.
Bye-bye.
Bye-bye. Thank you.
Bye.
Bye.